Assalamualaikum and hi, my name is Abdullah bin ABDURAMAN. My metric card number is DE210030. And in this video, my group and I will present about our group assignment for subject Computer Architecture and Organization. And our lecturer is Dr. Nik Shahida Afifi binti Tajuddin. Our group member consists of 3 people that lead by Alya SYAFIQAH, followed by CHAO, and me, Abdullah. Our group number is 13.
My name is BINTI and guide method is DE210017 and our from group 30. Today I will present about the introduction. First is RoboFront straight line imaging datasets management. Second is Euro revolutionary object detail view real-time inference. The third is Google Cloud provides GPU resources for efficient model training. The last is together then empower developer to strictly construct and deploying precise object identification system, advancing computer version capability. Thank you.
Hi again, and next I will explain about the methodology. Okay, first of all, this is the link. We have link for our dataset, and then for this project we use several software, which is RoboFlow and also YOLO V8. The first step for this project is to obtain more than 200 pictures for our object, which is the chosen object for our group is a cucumber. Then we use RoboFlow to detect the cucumber. There is an auto feature for the detection in the RoboFlow, and also we did a manual feature if there is a missing part or for our several picture of cucumber. After that, we export the dataset from the folder to YOLO V8, and each picture of the cucumber has its own code. Last but not least, we execute the coding by using the code that I will explain for the next slide. This is the coding. First, we synchronize the Google Drive and also the Google Colab. Then, second, we allow the Google Drive content to be referred. Next, this is important as to we need to custom objection models. And for the final step of the coding, I will explain each line of the function. First is to communicate with the operating system. Second, to import YOLO class from the ultralytic library. And third, to generate YOLO class and initialize. Lastly, to execute and set the epoch that needed in our group assignment, which is starting from 5, followed with 10, and lastly 20. Okay, this is the few picture that we obtained from the Kaggle. Okay, next I will explain about the step for training, validating, and testing. First, we have to preparing the dataset. The dataset can be organized by image and also corresponding annotation files. Second, we set up the Google Colab by opening a new Google Colab notebook and ensure that we have access to the GPU. Third, we install dependencies, including the ultralytic library for YOLO V8. Fourth, we mount the Google Drive. And fifth, we do a little bit of the configuration files. And sixth, we run the training to make sure the configured YOLO V8 model from our ultralytic to train our model on the training data set. 7, to evaluate on the validation set, we use evaluation script. And 8, for the last, we test on the data set.
Assalamualaikum warahmatullahi wabarakatuh. My name is Alya binti Abashah. So for this presentation, I'm going to present about result and analysis. For this slide is about precisions and loss for every batch. This graph represents for result of 5 epoch and 10 epoch. For 5 epoch, for every epoch, it will correspond to a complete iterations of the training dataset during the training. So for 5 epoch, as you can see, the increasing number of the epoch usually increase model performance since it's allowed the model to learn more about a data. So for the 5 epoch, it will be no overfitting and let the data perform positively. So for the 10 epoch, in this graph, it will start to overfitting. The third graph is 20 epoch. So in this 20 epoch, it usually increase model performance since it's allow a model to learn more about the data. However, this graph will be start to overfitting because it been using too many epoch. And the result might be overfitting, which is occur when the model recall the training data too well and perform negatively on fresh or unseen data. Next, in result and analysis is about correct detections. For every epoch, it has his own detections based on the epoch. So, for the 5 epoch, it can detect 0.3 to zero point 0.4 only. But for 10 epoch and 20 epoch, it can detect between 0.3 and 1.0. Next, other than correct detection, it has a misdetection. Misdetection sometimes happen when a object and image is present but it's not be picking up by the algorithm. So in this project, we see that 5 epoch have the misdetection other than 10 epoch and 20 epoch. So for the analysis for this project, we can see is that epoch 20 is much better than epoch 5 and 10. This is because we can see the predictions for epoch 20 is higher point and manage to identify all the object that we use, which is cucumber. Meanwhile, at the epoch 5, we can see that some object cannot be identified and has a misdetection.
In conclusion, combining RoboFrost, Euro, and Google Colab straight-line object detections for dataset preparations to model deployments, RoboFrost manage dataset, Euro offer accurate detections, and Google Colab provide computing power. Mastering this tool enables inference model development for various applications, fostering continuous learning and innovations in object detection and machine learning.